Welcome everyone, or one, to class. Um, Today we're going to talk about how to create data using your phone. I'm going to kind of go through, I don't want to say quick spiel, but the main thing we do want to focus on is looking at some phone apps, and you can join us online or join us later using phone apps, and then we can also connect it to this high quality GPS unit here. It's called the Geode. This thing runs about $3,000. And so it collects high quality or high precision GIS data. And so our focus of today is going to be creating GIS data from scratch. I think Dr. McGinn talked about the idea of he used to put a GPS on his car and drive around and collect, GPS data for street center lines back in the day, probably 20 years ago. So a lot of the existing data is in existence that can be improved. But at some point in time, you're going to have to go and collect data on your own. When I worked for the military, we used to go collect, ranges and firing points on military installations, and hopefully you weren't able to download those off the internet. And so we would go and collect these and keep these on secure servers, and then also collect information about each of those. And those are some of the things we talked about yesterday with attributes. And in this day and age, it's really easy to go and create new features. You can see I'm logged into my arcgis.com. I can create an app. An app is basically like a web page that you can't change, but I can create new items. And so I can drop and drag. I can create feature layers. Those are the equivalent of feature classes using ArcGIS Pro. Things from URLs, applications, but I can create a brand new feature layer and I can define my own layer. I can say if it's a point, line, or polygon, and maybe some more complex features. I can use templates, URLs. I don't do this too much because what I like to do here is I can go and create a brand new project right here. And this is how I used to do it, but in our catalog, we have a new file and I can go right mouse click, new, feature class, feature data set, table, view, relationships. You can see some of the, geometric objects we can create. So I can create a brand new feature class right here and I can call it, Tim points. And I can say if it's a point, line, or polygon, I can say that it's a point right here, next. And then I can also add brand new fields. I can say, all right, this is going to be a description. It's going to be a text. And it's going to have a length of 50. So we can, as we go through and create these, I can say what the state plane, the projection is, and we'll talk a little bit more about projections in a little bit, because these days, the way that we consume our maps are using via the web. And so, we have this thing called Web Mercator, WGS Web Mercator, as opposed to state plane, because if I zoom in or zoom out or definitely zoom out on North Carolina state plane, it's going to make the rest of the United States look really odd, because the whole goal of North Carolina state plane is to minimize distortion for the state of North Carolina. It doesn't really care about. But you click this little spinner and you're zooming out from North Carolina. And so we have something that looks good on the web called Web Mercator, which is starting to be integrated a little bit more, a lot bit more into our GIS. But I can create a new feature class, and then here it is ready to go that I can digitize on this map right here, or I can load into my phone using field maps. And I think I've given everyone the ability and capability to look at one of the maps here attached to our project that we'll talk about here, in a little bit. So Tim points, I can go to edit and I can start editing things right here, because later what we're going to be able to do is I can go to add data and I can look for data attached to my classes. Oh, hey, Ahmed. And so I can go to data attached to my classes. And so I can go to my groups, my organization. And since you're all added to my groups, you can see I've created something here called Landmark Summer 2024, and I can add it. Now, these are all the landmarks collected from all of our previous versions of class. So you can see people in, I think we had someone in Colorado, we had someone in Florida last year. And so these are what we're going to do today is we're going to add this to our field maps. and then we're going to go out in the field and collect it. And then using our GPS unit, okay, our phone, or we can connect it to our GPS unit just using some simple Bluetooth and make it look a little bit better, probably 10 to 15 feet better or whatever. But now I can, you can see here, I think this is last summer or wherever I was, but you can click on the little points right here. This is my boys' bedroom. But here's some of the information that we collected about it. I don't know if I've got a picture there or not or whatever, but and then you can see Dr. McGinn, he collected some imagery over here and you can see him. And then some of the GPS parameters that we collected, and you can also see the creator, the username that created this. So there's a lot of information out there. So we're going to go and add to that. You can see many of these are going to be around campus where I kind of just send people on a sojourn here around campus and go collect some points. So what we did here, we had some people collect the student center right here, and you can see what the student center was looking like in 2022. When it was being constructed here. So these are some really neat things that we can do here. And then we can also, and what the homework for tonight is going to be is you're going to create a survey. And so what do you want to survey? Points of interest, mountain bike trails, waterfalls, telephone poles or whatever. And you think critically and holistically about what are the different things that you want to collect about a telephone pole in order to do that. So I'm going to talk till about 10 o'clock. And then we're going to do our field stuff till about 11. And then right in 12:29 behind me, we're going to have a meeting. We're going to have a talk by PhD on meteorites, and they are serving lunch. So, free lunch. So those are my two favorite words. And, I've gotten free lunch all week. Went to a thing on health disparities yesterday. Free lunch, nice lunch. They had a little popcorn machine. It was really cool. And I was so inspired that I went and bought my wife one for Mother's Day. And her birthday is right after Mother's Day. So it's double dip. Yeah, I just double dip. This is for both of them. Nice Amazon man. It's going to be, me and the Amazon man, we're on a first name basis. My wife loves Amazon, but this time I got to treat her a little bit. So. But all kidding aside, you can see some of the points that we've collected. And so these are ways that you can collect data out in the field. Some previous projects we had a student who was who worked as a health inspector. So they went around to different stores where they lived and took a picture of it. And this was the health score of that particular area. So you can see the applications in the field of these, whether we're doing things like site inspections, things that can be done in real time where we want location attached to these. And so we have things called quick capture. And as you can imagine, quick capture is probably used to capture something really quick, where that survey 1, 2, 3 is we collect information. And right now we got a student named Benjamin. Does anyone know Benjamin? Yeah, Benjamin, guy with the beard and stuff. Yeah, Benjamin. But right now he's collecting data on staples. Bananas, milk, bread, and he goes around to about a dozen different stores on a monthly basis, and he just collects information about staples. So the price of bananas today is this, the price of bread is this, and so it brings it into an Excel spreadsheet in addition to a GIS. So we can export those attribute tables as well as those spatial data to do whatever we want right here. But this data sitting right here is in the cloud. And the last thing I want to kind of look at before we look at this, where I right mouse click and look at properties, you can see this thing that I just created, this feature class I just created is sitting at C, TIMS, Documents, ArcGIS. It's sitting in that GDB. It's sitting in that GDB right here called TIM points. But this landmarks, if I right mouse click and click on properties, I've got to go down here to landmarks 2022 because I called it 2024. Right. But I go to the source. You can see it's got a dedicated URL sitting there. Basically, I call it landmarks 2024 because I just renamed it from 2022. and renamed it from 2023 and 2021 when we taught it. So because I don't want to create a new dedicated URL for it, I just want to add to the points that we had added to in the past right here. And so it's got an alias called Landmarks 2020. It's got a alias called Landmarks 2022. So the hierarchy for these is a little bit different than what we work in our a little bit different than when we work in with our GDBs, and those are things I'm still getting used to, as well as some of the taxonomy that we have. So we'll talk about coordinate systems here, because the nice neat thing about this is that all these things line up on a nice pretty base map. You know what I mean? So I zoom out here, we can see James, who took this class virtually, he's down here. Dr. McGinn and myself, we're out in Guilford County. There was someone out in Salisbury who took it, and I think we had someone who was in Florida, Pensacola or something at the time, and then someone in Colorado, and then someone here. I think Lauren was here. Lauren Johnson might have been here or something.
Yeah, I think she was. Yeah, exactly.
Yep, Nana's house. Yep. And so you can see Nana's house right here, and they were signed in. They might have been signed in as like a GIS, but you can see when they collected 5/14/2023 at 10:41 p.m. And we got the exact lat long. They collected it with an iPhone 13. Do you think they went and typed in all this information? No, this is all information and parameters that we can collect. So the more, the better. And definitely the more, the better. So we can see this was collected with that. So some really neat things that we can do with this here. And right here, we've got Landmarks 2024, part of a web map right here. I can open this now up in ArcGIS Pro. So I can open this up in a map viewer. It's sitting right here in a map viewer that can be edited online. Here are the points right here. And then from here, I can create a nice web app right here, because in theory with this, I can go and add elements to this map here. If I want to share this map but not have you add these, I can create something called a web app. And so we have instant apps, story maps, which we all know, experience builders, which I've talked about the other day. And I think we're going to talk a little bit more about those tomorrow on how to render and display your data. We have a student, Mike Wallace, who works for North Carolina Department of Environmental Quality. I don't know if anyone knows Mike, but he was a non-traditional student, came to us from Guilford College, history and education major, and kind of worked in music. And he did stuff with swine lagoons, and then got onto a project with DOT. And he got into these web experiences, which were amazing. Were great things that people want to see. Focused on redlining, which is really just a pertinent issue, especially here, with our mission here at NCCU. And so I can insert these into a nice little web app right here, and here we go. We can do atlases, viewers, basic. Here's a web page that I'm inserting this into so that I can change the colors. I can put logos, titles, everything, so people can't screw up my map here. And so there's lots of ways to display and render your data. And now in this day and age, Andy is Web Hub. We got these Web Hubs. So these web pages that you can make, insert pictures and videos and all that other stuff, but then now you can share your data right here. And so I can go to my landmarks, or I can go to everything else right here. I can go to my landmarks and say, all right, I want to share it with, I swear I know what I'm doing, but I can share it with my groups. Okay, I want to share it with the COPE Hub. Okay, so this COPE Hub right here, the data followers right here. I'm creating something called CODE, Center for Data Equity, Coastlines and People. And so these are all the groups that we can create in support of this. So when I create an open data portal, that this can be shared explicitly and specifically for them and them only, or share it between multiple groups as well. Last thing, we got usage. So we can look at the usage of this thing, landmarks, so we can look at this thing over the past 12 months. And we'll kind of look at this, and then we can look at the settings right here. So down at the settings, I can say, hey, we can't edit these things. We can't export these things. So I can really kind of play. This is the actual web map itself. But when I look at the feature layer right here, okay, so the web layer, the feature layer right here, I can click on settings. And so can I allow data to Can I allow the data to publicly collect it? Yes. Can I allow people to edit it? Yes or no? Can I add people to add to it? Update. There should be a ability here to export it here. Who can manage the edits? Me, data creators. Look at all the different things. Allow others to export. I click no right there and you go to right mouse click. Guess what? You can't export it. So you got the power on what people can do with these things here. Okay, we're at a point right now where I don't want to say I don't care, but we want to give everyone the ability to do it. And so there are people that live and breathe in this space only. And Andy and Sarah are a couple of people who are really good at managing the cloud-based data. Because you can see right here, I've got some cloud data sitting here, and then I've got some data sitting right on my computer right here that live and breathe, pretty well with each other. So we're going to talk about coordinate systems, making things line up. Believe it or not, the world of projections and coordinate systems is changing to this day. And we have a new geographic coordinate system that's coming out. We have a new geographic coordinate system coming out where like I said before, the size and the shape of the Earth is changing slightly. I'm not sure when it's going to be integrated into any of these things, but this is run through NOAA, National Oceanographic and Atmospheric Administration. And this is with our geodesy division. So they have a division called geodesy, which measures the size and the shape of the Earth. So there's books out there that just study the size and the shape of the Earth. So if you have a surveying background, you're probably pretty good at this with the sines and the cosines and tangents and all that other good stuff. And I've got a book sitting in my office. I can probably fake my way through the first third of it, and then it gets real ugly real quickly because things that geoids and ellipsoids can't approximate are elevation, sea level change, all the undulations on the surface of the Earth that we capture using drones and all that other stuff here. So I'll talk a little bit about this for about half hour, and then we're going to load these up into our phone, and I want to make sure that we can go out and actually collect data. We've got our GPS unit that we can collect. So the app called Geode, G-O-E-D-E, you want to download that as well. And it just connects via Bluetooth. So you get higher precision GPS, but these days, these phones are pretty good for GPS because they're not collecting via satellites, they're collecting via your cell towers, which have distinct lat and longs attached to those. So we'll talk a little bit about projection systems, just making everything line up. I know Dr. McGinn can attest to the fact that making everything line up in a GIS 20 years ago was really much more difficult than it is now. Because right now, these days, when I open up ArcGIS Pro, I've got a reference map that's already geocoded sitting right there. The previous versions of ArcGIS that we had, like I migrated in 2020, which was a long time ago to you all, but not a long time to me. Like it came up with blank maps, so I could create junk data the whole time. I wouldn't even know that it was bad unless I added a base map or reference map. But these days we have the
I think my master's thesis, some of those North Carolina maps that I made are still stretched out in the wrong projection, and I look back and I'm very embarrassed by those that were published in my thesis. So yeah.
Oh, okay. Yeah, we have those too, where it's stored as North Carolina state plan, but we display it as geographic, and it stretches those out. And so, the aesthetic, in addition to the types of colors you use and everything else, are just as important as the projection you have. But these days, how do we consume maps? On our phone, on our computer, I hit the little wheel, slide wheel, and I'm zooming in, I'm zooming out. And so this is just another skill that you have to pick up, meaning you got to, at some point in time for papers or posters or whatever, you got to make a high quality map that it's going to be static, but we also have to learn how to go to ArcGIS Pro, click that share button and share it with the world using what we call web Mercator projection. So we'll talk about those. The main goal with these, with geographic coordinate systems, is that we want to have defined datums, defined coordinate systems, so things can be overlaid on top of each other. And I know in data science class and maybe geostatistics a little bit, where that I try to display data using incorrect projections, and it looks really funny and really odd or whatever. And we did that a little bit with geocoding, where we didn't add the city. And so it saw 27 Main Street, and it just found the 27 Main Street that it wanted to find. So qualifying data and locating data, there's a lot of front end work that needs to be done on your end. And even though in geostatistics we have the red maps and the blue maps and the pretty maps here, most of your effort is going to go into developing data. And this, making actual physical data from scratch, to me, it's extremely rewarding, where you're contributing to GIS, even though people love looking at the algorithms and everything else. But when we go to the NCDOT and download the road center line, and in data science class, we downloaded all like 1.2 million road center lines in North Carolina, and we wrote Python that ran checks on speed limits. And hey, we saw negative speed limits. Actually, I auto-generated some negative speed limits or decimal points, or has a speed limit of 32. Is that really right? Go through and check. Like, think about the time, energy, and effort that it went through to go and create those 1.2 million roads. People like Dr. McGinn, 20 years ago, were driving in with a GPS unit collecting these or digitizing these off of high quality imagery. We don't have to go collect roads anytime soon. If you do, good luck with that. Have fun.
I mean, that was literally the process. Was when new construction came through the Register of Deeds office, we would get it, and the roads would just be down before the neighborhoods, and we would have a little like geo car with the satellite on top, and we drive down the middle of it with the laptop hooked up, and it would trace the line, and then we'd go back and do it again, and then have to upload it and merge it in. It was a pain.
Yeah. Oh, yeah, definitely. So what we're looking at today are different types of what we're going to do here. You can see who created it. We have different points right here, and that's what we're going to do today at about 11, where you're going to connect to my data sitting in the cloud, and you're going to add to it. And then we can export it or do whatever you want. And so think about some big projects that you want to do. You want to go collect staple prices, or you're working for a utility company and you create a survey where, all right, what's all the information about a telephone pole that I want to collect? And you can use something like this, which is going to get real exact. I would love a project where that, Ahmed and Andy go out and one uses this and the other one uses their phone to see how close these things actually mix and match. Because when we start doing like AIML of trees, like this thing might not be good enough. Like, hey, I've got a tree right here. Let's see if the tree can be identified using AIML techniques. And then let me use this to see if the tree can be the tree is right there because I've got tree. And if this thing's telling you it's a tree and it's really not a tree because it's 20 feet off, what's that going to do to your AIML, and maybe more important, to your cross-validation? The assessment and evaluation of the techniques and algorithms, and those of you who take my classes, that's a big thing with me. How do we assess and evaluate your algorithms, techniques, whatever? Even if you write a little computer program, how do we test how quote unquote good it is? All right, I'll get away from my tirades right here, but you can see some imagery we collected, using drones, GPS units. We've got things like horizontal accuracy and other accuracy. We can see, oh yeah, this is a landmark. I guess I had a kid taking a nap there. So, but these are things that we can collect. All this stuff that we can collect right here, like GDOT, PDOT, HDOT. those are dilution of position. So some of these things which they mean, and if you can collect it, because that's what this stuff is collecting. That's what these things are collecting. In my prior life, when I worked with the military, when I, went out in GPS, these things right here that were used for analysis, figuring out, hey, what kind of weapons can we fire on this particular range? Like people wanted to know this information right here. And this stands for dilution of position. We're at X, Y, T. And these are all parameters that we can collect in there. So when you click on one of those points right there, your phone is actually collecting that. Just like the drone yesterday, where you didn't have to type. It was a Hasselblad or whatever it is, Hasselblad. The lat, the long, the exposure time, all that other stuff. It's being collected by the drone for us right here. So when we look at satellite geometry, because this thing is really neat, where you load this thing up and you can see all the satellites that it's connected to. How high up are those things? 10,000 miles, 12,000 miles? I'm looking right at Andy, expecting him to know. So
It's very high.
very high. They're not geostationary, but they're high. They're not like with the space shuttle, or I guess there's no space shuttle, but whatever, something, the things that are going around. They're not with Sandra Bullock or whatever, in gravity, going around there, 10 times a day. But they're up there, and you can see that satellite number. Back when I got into this, I think there were about 32 satellites, but I see like satellite number 40, 42 or something like that. So I assume there's more GPS satellites up there. So this PDOP and GDOP, you just want coverage from across the sky as opposed to coverage in different areas right here. Because what we're trying to do is collect precise or high quality, information, spatial information, 15 feet. All right, that's good for maybe your phone or whatever, but there's a lot of other parameters that get into it. And like I said the other day, when I got into GIS, I wanted to get into remote sensing, but there's so many things that can happen between your satellite and your, satellite and the thing you're trying to capture, like, Rayleigh scattering, Mie scattering. Does that stuff ring a bell? The different types of scattering? Raleigh. Okay, Michael's nodding his head. I know what I'm talking about here a little bit. Well, all the different things, spell it, reflectances and time of day and all those other things. And so you run into some of those other same challenges when we go and collect high quality data. And so these are some of the things you have here. If I were to turn it on in here, it'd probably be a little bit difficult to collect, because I did try collecting some points in my room. And it's like, hey, the GPS or even your phone's, your satellite isn't, the tower isn't collecting. So you have, things like multipath. So you want things out in the open, but hey, if I'm collecting a tree that's near the building right there, you can't move the tree or whatever. So you might need to wait for a time of day or whatever. So there's lots of different types of GPS error that we can run into with the ionosphere. Make sure you have the correct units. This was in the late 90s, where one team was working on the Mars mission. I forget which one it is, but one group was working with metric units, another was working with English units. And so if I remember right, it deployed the parachute too close to the ground and it crashed. So we sent something to Mars, and so these units are important as well. And most of the times we work with meters or centimeters here, which I think most of the world except for us know. But being able to convert between the two, I think, is important. We also have map scale. Map scale is unitless. It's basically world distance to map distance, or vice versa. So if I say something's 1 to 1,000,000, that means 1 inch on the map equals 1,000,000 inches in real life. How far is 1,000,000 inches? Pretty far, really far. And so when we create these scales, now the one thing these days about maps, when I create a nice pretty map for exercise number 2, you created a map that had a dedicated scale. But the second I start hitting this wheel right here, I'm changing scale. So we look at data at different scale all of the time. And this is something a lot different than 20 years ago. I'm making a map with what we call a layout, and it's going to be a dedicated layout. So all the maps you see around here, they're all that created about 1 to 1 million or something like that. And so there's always this arms race between resolution, how much detail do you want to show and how much map do you want to show. And so I think I have it right here. Oh, I don't have it here. But typically there's 63,360 inches in a mile. So 12 times 12 inches in a foot, 5,280 feet in a mile. And so a lot of times you'll see map scaled at like 1 to 62,500, 1 at 63,360. And basically 1 inch on the map equals 1 mile on the map. Now, when I work with the military, we'd make maps at like 1 to 50,000, 1 to 25,000, some of them at equal 1 to 12,500. But as you get more, better, lower, or higher scale, you get more detail, but the map gets bigger and bigger. And so we worked with a military installation in Kentucky where they used the military installation for hunting. So they wanted like a 1 to 12,000 scale map that they could fold up in their pocket. Like, just doing the math on it, hey, it's about 5 inches to a mile, and your installation's about 10 miles wide. So we're looking at about a 50-inch wide map, at 1 to 12. So it's going to be really, detailed. So you can see your hunting areas and the cemeteries and your firing points and everything else, but it's not going to be something you could fold up in your pocket. And then we worked with places in like Nevada and especially Arizona, which might be like 20 miles wide by 20 miles wide. And, even at 1 to 100,000, you're still working with the good size, it's still good size maps that we're working with. So we're not making those at 1 to 25,000 where that, we're going to be 40 inches wide or whatever. So we've got map skill so things can line up. I get really into the weeds right here, but we've got geographic coordinates right here. And so you can see up here in North America where we are, we have, we're basically in the second quadrant. And so these geographic coordinates are angular distances. So when we convert these to real world distances, we got to bust out our sines and cosines and tangents and all that other stuff. So as we move further and further north, one parallel has a smaller distance than the next parallel down at the equator, and it decreases by a factor of the cosine of your latitude. And so at 30 degrees, the cosine of 30 the cosine of 60 is equal to 1/2. I'm just looking to make sure we are trig folks. Is that right? Yes, cosine of 60 is 1/2. So at 60 degrees north latitude, it is half the length of it as it is at the equator. And so here where we are, if we were to walk around the Earth at wherever we are, 37 degrees north latitude, it would be about 80% of what it is at the equator right there. Even though 1 degree of latitude is about the same, so we're traveling north, this distance is about the same. We've got flattening and all that other good stuff there. And so I've got some information here about these geographic coordinates. Also, there's multiple ways. So when you go to ArcGIS Pro, down at the bottom, you can display data as decimal degrees, degrees, minutes, seconds, degrees, minutes, seconds. Degree, we know what a degree is an angular unit here, but a minute is 1/60th of a degree. A second is 1/60th of a minute. Me personally, I just like these, so I can convert these nice and easily, really quickly, but you see a lot of these. I took a cartography class in like 1999 where we had to go kind of hand calculate between these. ArcGIS Pro does them for you. Okay, ArcGIS Pro. So we had to go and do this nasty math right here, where it was 35 divided by 60 plus, this is how you convert between degrees. And they're based on the prime meridian right here, which runs through Greenwich. So a lot of times when you set up like your phone or your computer, you might see something that says like GMT -5, or what do we hear, -6? What's Nigeria? Is it right on GMT plus one. Okay, so GMT plus one, we're GMT minus six. It was interesting because in France, we're minus five, but places in France are actually like west of, west of England, which is minus six. And so you can see some of the things about the standardization, latitude and longitude in late 1800s. So that, what is noon? Noon is when sun is highest overhead, but, even here versus Greensboro versus Raleigh, those numbers are going to be slightly different. So the standardization of those kind of came about. Also, how do we, in this GIS, how do we approximate the size and shape of the Earth? Like I said before, we've got new datums coming out where the center of the Earth is moving about 2 meters. And so we've got really high quality equipment that give us the ability to measure it, where that the Earth really isn't a sphere, it's more like an ellipsoid. This is very exaggerated, so the flattening ratio is about 1 to 300 because the Earth truly isn't a solid, it's more of a semi-solid. And so when it spins, it's got the centripetal or centrifugal force, one of those forces. So it's got a little widening or bulge at the equator because it is stretching out. And so we've got different data models. We have a sphere versus an ellipsoid versus a geoid. And then we have these models here that help approximate for topography and sea level, which change on a fairly regular basis. So when we look at the properties, you can really get into the weeds. So someone coming from a surveying background can maybe appreciate this a little bit more, where that we've got about a 1 to 297, 1 to 298 flattening ratio for the sphere, which it's going to be difficult for anyone to notice by hand or by eye. And so we've got the Earth-centered coordinates right here. This is basically how we have our lat long. So when we measure latitude and longitude, it's angular distance from the center of the Earth. So even if the center of the Earth is moving a little bit, these 1 degree of latitude and longitude is going to be slightly different. Are we going to notice this? Our GIS, it's probably not even going to be, it might move literally an inch or two when we put it on, but it's not going to notice. Now we also have coordinate systems. So coordinate systems, and where we start to project 3D data onto 2D data. Oh, okay. And so our generalized ellipsoid, we can see here, we have a semi-major, semi-minor axis. So if you were to get into the weeds for some of these projections, it would give you the semi-major and the semi-minor axis. It's truly not a circle because in a circle, the semi-major and the semi-minor axis are equal to each other. So these are some of the different reference ellipsoids that we have. NAD 27, which was created in 1927 based off the Clark 1866 ellipsoid, and we're getting better and better. So you can see the actual size and shape of the Earth are actually changing. Why? Because the way that we've measured them has gotten better. That's it. Okay. And like I said, I think the furthest people have dug down to Earth is like, 6 miles, something like that. So, but the way that we've gotten to measure it. So every once in a while, you'll see like Mount Everest is raised a foot. No, it didn't raise a foot. Just its official height is, 29,035 feet instead of 29,029 feet because we have much better measurements now. And so these are some of the challenges, and I think probably Dr. McGinn ran into these when you bring in data from NAD 27 to NAD 83, it's off like a couple hundred meters. And so when we worked with the military, and I think this is Fort Polk down in Louisiana, we would get data for this and they would say, oh, it's NAD 83, but it's off. And so, no, this is the wrong projection. So I wouldn't just select it and move it up. We would change the projection. The projection would just magically pop it right there. And so in data management in ArcGIS Pro, there's a whole lot of utilities in there. Change projection, reproject, all those other things. ArcGIS Pro reprojects everything on the fly. Like previous versions of ArcGIS didn't do that. You would have everything in the same projection for it to be displayed on top of each other. So I had to go through, all right, what is this projection? Let me go through and change the projection so it can line up with each other. And so we can change the projection. Now we want to store data in featured data sets, which are containers within Geodatabases, they need to be in the same projection. And that's what I worked with in the military. We had a military operations, we had a transportation, we had a recreation, we had a water and wetlands feature data sets underneath everything as part of our SDS FIE. And so you can see some of these. But when we go to ArcGIS Pro and look at the coordinate system for a particular map, this is all the nasty stuff that goes on in the background that we don't really think of. So we have different projections, basically how 3D can be projected onto 2D, because our screens, everything that we look at is 3D or 2D. You know, like I said before, when we wrap up a Christmas present or birthday present or anything like that. And so no matter what, we're always going to have some type of distortion. We call it SAD, shape, area, direction, distance. So like I said the other day, you can see the top edge of North Carolina is curved in those maps in the back. It's not curved in real life. But when we create that projection and I flatten it, the North Carolina State Plane projection is going to distort this direction a little bit, so that east and west really isn't left and right. It's along this slight curve. I noticed the curve right there, but you're not going to notice it in real life as well. So those are some of the things that you have. So when you have the geographic coordinate system that Dr. McGinn was working with on his maps, it's going to be true to latitude and longitude, but it's going to stretch it out. And so there's always going to be some type of distortion with any map that you make. Now, Web Mercator is a happy medium because I'm going to click my little spinner. I'm going to zoom in and zoom out. And I start zooming in and zooming out when things are in North Carolina State Plane. You're going to notice places in the other part of the United States are going to look really odd really quickly. And so we have like African and North American and European and Michigan Upper Peninsula projections there, whose goal is to minimize projection for those particular areas. And so we have different types of projections here. We've got Albert equal area, sinusoidal, and obviously the larger the area you're trying to project, the more difficult it gets, the more distortion you're going to see. So in North America, we've got a North American conterminous projection just for the 48 states, because it doesn't want to kind of account for Alaska and Hawaii, because when you're mapping Alaska and Hawaii, you're also doing much of the Pacific Ocean and Canada and everything. And so you're mapping that larger area. Like I said before, they've got a UP projection, Upper Peninsula for Michigan. They have a Long Island projection because Long Island kind of juts out from the rest of New York State. So they have a specific Long Island projection that someone created. So these are some of the different map projections. Some of the terms we have are standard parallels. So when we have a projection surface like a cone or what are those cylinders, project with it, you'll see these things called standard parallels where we have minimal distortion and then we have distortion at these other areas right there. But once again, this is what we call a conic projection. I can see these are conic projections because the top edge of the United States is kind of curved. So east and west really isn't left and right. It's along this curvature right here. It's generally east and west, but not quite. And then in this particular case right here, the north and south isn't up, but it kind of points to some point or goes to some point way up in, North Pole or whatever. And so we can look at this information right here, and that's what all this stuff means right here. I don't care, I don't think any of us care about it these days. Once in a while, if I get some really bad data, I do. And so we have different types of projections. I like this one here. This one's kind of neat. It's called a mnemonic projection right here, but it displays the great circle as a straight line. So I like this where the pole is the polar projection here. So I like this one because what's a great circle? What's the shortest distance between 2 points on a flat surface? On a flat surface is a straight line, right? On a globe, it's the great circle. So a lot of times when you fly from the West Coast to like Japan, you're kind of flying up near Alaska because that's the shortest distance. And if I were to show this on a traditional map or projected map, it would look like a big arc, but on this one, it looks like a straight line. And so you would imagine, this straight line right here, if we fly here, it kind of looks like this, but this really is the shortest distance between the 2 points on a globe, even though, I could just draw a straight line right there, but that's not the longer distance. In addition, we've got different types of projections, the way that we display data. This one's called the Mercator projection, which is a cylindrical projection, but we have kind of what we call aerial distortion, where you have Greenland up here. It's about 840,000 square miles. It looks to be about the same size as South America or Africa, but it's really small because it approximates the size of the Earth or the shape of the Earth to be a cylinder, which it really isn't. But the good thing about this is that your lines of latitude and longitude meet at right angles. And so you have other types of projections where they don't. We have projection systems in the United States. We have one called UTM that we work with in the military, where the US is divided into 6 degree of longitude wide zones. So there's 60 of them. 60 times 6 is 360. And so what zone are we in? What UTM zone are we in? This is what we worked with in the military. And so Fort Liberty is going to be zone 17, zone 16. There's a place right here called Fort Pickett. I think it's got a new name right now here, but sometimes they would give it to us in zone 17, sometime in zone 18. We didn't know which. So, all right, if I made it zone 17, it would be over here in the ocean. Okay, I guess I got to change the projection. It's literally right on the line right there. And all it does is just create a false northing and a false easting point where it creates some 0, point. And like I alluded to before, down here in Alabama, there's a 0, point for the North Carolina State Plain. So we just have everything. It's literally right here in Alabama. So right here, everything in North Carolina is going to be in the first quadrant. All of them are going to be positive numbers. Why? Because of the focus on North Carolina. It doesn't care about Alabama or Idaho or any of that other stuff. And each of these states typically have their own projection. Larger states like Texas, or weird shape, I don't want to say weird shapes, but oddly shaped. So something like New York will have a Long Island projection and then the rest of New York projection. Something like Florida probably has a north and a south, which use different projection systems. And so we have false northing and false easting. And the last thing we'll talk about here is, metadata. When you create these data, we've got metadata that store these. This was the focus of my dissertation. It's probably not the sexiest or funnest subject there, but it's something that is needed. And so when we go to North Carolina one map, it's got different tags right here. And these days, in the day and age of hubs, we can really decrease the amount of duplication on data. One of the biggest problems we run into is, hey, I need to go get all the counties. Well, you go to Andy and Sarah's hub, you type in the word county, we can download all the counties for North Carolina sitting right there because we've populated the metadata. Okay, hey, I want to look at water quality. I don't need to go out and calculate water quality. I want to go get all the hog farms in North Carolina. Guess what? They're already sitting there on NC1 map. You go to NC1 map, type in the word hog farms, they're there ready to go. Now, at some point in time, what we talk about today is, at some point in time, you're going to have to create telephone pole inventory for NCCU. Okay, this is where you make your big bucks and can contribute to the GIS. And so we've got metadata right here. This day and age, metadata is really important. You can see ArcGIS Online has metadata, and what I like to do is I can import or overwrite data. So, hey, I can import it. Hey, this is for my NSF project. This is for my NASA project. This is my contact information. And then I can change the tags and the description specific to counties versus, hog farms versus schools or whatever that we're looking at. And so metadata, it's important. Okay, really important. We got different state plane projections. We've got geodetic surveys right here. And so we see these monuments out here every once in a while that give you your exact latitude and longitude that help dictate projection for North Carolina, as well as the size and the shape of the Earth. If you walk across Fayetteville Street to the Dr. Shepherd statue, and you're waiting right there for the cars, you look probably about 5 feet to your left, you're going to see one of these things just sitting right there that you can look up from the USGS. When I worked with the military, people wanted maps that had these things on it. These are specific for the North Carolina Geodetic Survey, but you'll see these survey monuments sitting out there for the USGS. And then you go down Fayetteville Street a little bit in front of Lee Biology Building. You see another one of these things just sitting right there that have the exact latitude and longitude that we can use as control points. And so we can go and download this thing. I think that one is called like Grandfather or something like that. That's up in Avery County here, but we can see the exact geoid height, lat, long, all the map stuff that kind of goes into telling us what the exact latitude and longitude down to like the nearest like sub-millimeter, tenth of a millimeter. Really neat stuff here. And so we can download these. We can go to other places that have, your lat, your long, your elevation, these monument tree coordinates or whatever. So there's a lot of kind of potential out there for getting your exact latitude and longitude. So it's 10 o'clock right here. What we're going to do is we're going to go and I created a survey. So there's a couple things that we're going to do. One thing that we're going to do for the homework, what you're going to do is you're going to go to survey 123 and you're going to make your own survey and share it with us. Like what does Michael want to collect? He wants to go to his apartment and collect all the green doors or the points of interest or something like that. What are the things that we want to collect about this? You can see some of these that we've collected before. What I did for this class was a few years ago, I went and created a feature class that we're going to add to. So I created a feature class. It's called Landmarks 2024. And I guess a subset of it is Landmarks 2022. And then what you're going to do is you're going to go create a description and take a picture of some places around campus. Now, in order to do this, okay, what we're going to do, I want to make sure everyone has it. There's an app called Field Maps, okay? An app called Field Maps sitting right there. We also have one here called Survey 123. Because at one point in time, when you create a survey on your computer, are you going to be walking around with your computer, collecting the survey? No. You're going to load that survey onto your phone and collect the information. Hey, there's a picture, there's a URL, obviously latitude and longitude. What's the price of eggs? Let me take a picture of the price of eggs. So what are all the things that you want to create? Because we're going to log into this thing. Uh-oh. And then when we look at these, hopefully and we click on maps, you're going to see a big, gigantic list of maps. So I want to see everyone here log into Field Maps, and then what we're going to look up is Landmarks Summer 2024. So those of you joining us online, what I want you to do is, when you join us later, Landmarks Summer 2024. Can you see that? Landmarks Summer 20. Now you see all the maps that I have here. I have someone named Brandon and I was working with maps. I've got COVID maps. I got tons of maps that I've shared out here. And some of these probably accidentally, but Landmarks Summer 2024. So you're going to have to download Field Maps. And then what we're going to do is we're going to add a map right there. You're able to download it and log in here? All right, installing. Okay, cool. ArcGIS Field Maps. And then while you're here, also log into Survey 123. Me personally, being old, I like to create my surveys on my computer. Okay, so with the Field Maps, I went and created the later and shared it with you. With Field Maps, what you're going to do? You're going to create the survey and share it with everyone else. So Andy can say, hey, Mulrooney can view it, but I don't want him messing with my data. Or we can allow it for groups of people, because you saw when I clicked on share, you got tons and tons of capabilities that you can share this with. So let's give everyone a minute right here, and we're going to go and while we're there, if someone wants to take the GPS unit, they can do that. But for now, I want to make sure everyone's logged in, because what we're going to do is walk around part of campus, walk down to the parking lot and collect some points. We can go collect a picture of my car or whatever. Okay, and then once you install and log into Field Maps, it's got a list of maps that you should have access to. And this is my worry here. I want to make sure everyone has access to those. All right, so you got so what we're going to look at is Landmarks Summer 2024. You got it? And when you click on it, what do you see? You click on the actual map itself. All you do is see a map and a blue plus sign at the bottom. What do you think that blue plus sign is? Add data. All right, and you click that blue plus sign right there and you can add data. If you look at the top, what does it say? It says GPS accuracy 35 meters. It looks like someone required 15 meters to be accurate. How far is 35 meters? That's like 110 feet. So when I actually zoom in, you can see that I'm off on the other side of campus, right? I'm off on the other side of the building, when in reality, I'm not. And I'm moving around right here. Still downloading. Okay, but I got a blue plus sign here. You click that blue plus sign, it says take photo, attach, and what else do I have right there? I got something called name. What's the name? Your bedroom or car or whatever. And then it'll collect all the other parameters. You can attach a file, take a photo, and then cancel. But what we're going to do here, and what I'm hoping people who are watching this later are going to do, is you're going to add Landmark Summer 2024, add that map, go around, walk around your house, wherever you are, because we got people in Colorado, we got people in Florida, and people, wherever collected this, go and collect some information. So it's 10:07 here. Let's go walk around a little bit, collect some information, and then let's see it added here, and then we'll go and add it back to our ArcGIS Pro, which I think is us being able to access it, and then we'll get started on our surveys. All right, so we're going to take about 15 minutes right here. And so those of you joining us online, you can do the same thing or go collect. It'd be a cool one if you added it. Go collect some points, and we can see some of the points you added. Landmarks 2024. Now, it should be right there. Click on 4950. There it is. All right, let's walk around, check it out. Go wherever you want. We have people walk across campus or whatever. This is the stuff that I like doing, is going out and collecting this stuff and doing it. Yeah.
either. There's no screen or projector. No.
What in that?
We can do what?
There's one in here.
Oh, yeah. Self-sufficient.
Mm. Mm. Oh, cool. I'm looking at some of the stuff you all did.
I thought it was time for us to come back.
Yep. Yeah, and we got that. We got the food out over there. We're gonna get some free lunch. I'm all into free lunches. I'm sure you are too, huh?
Yeah.
So what do you usually eat at home? Do you go out for like fast food or you make food?
Main food.
Oh, okay.
Still not used to most of the food.
Like Wendy's? Do you like Wendy's or anything?
Wendy's. I don't have Wendy's.
You don't want Wendy's.
tried using this. It's worked.
Okay. What kind of, how good, how close was it?
I got like 0.8.
Oh, okay, that's not bad.
Was that fun?
Yeah, the best I got with this was about 5 meters or so. Okay,
This is a lot better.
all right, you like this thing?
Yeah.
All right.
What I did was I just moved around trying to get some fire hydrants.
Yeah, I saw the fire hydrants out there and the bus stop over there. That's pretty cool.
What when the data?
Whatever you want with it. For now, I just added it to a web map and, you know, we're gonna create a web app out of it and all those other good things.
You want me to reach out to the others to start coming down?
Yeah, that'd be good because we've got that meeting that we're gonna hit. And I just wanna just show everyone what we've got and then they already got, you know, they got food out and everything and I think Ahmed's coming back here. All right. All right, so the main thing that I do want to do is, for those of us joining online, and I've been playing with it a little bit, is that when I go to the black plus sign and add these things, you can see everything that's been added. In ArcGIS Pro, it's a little bit harder to see everything that's been added, even though it's got 147 points. But when I go to ArcGIS Online and go to landmarks, and I click on Open in Map Viewer, it's got everything here that we've added. You know, Andy was talking about adding, you know, fire hydrants, and we're going to move over to the NCCU campus. Oh, someone was down at Falls Lake. No, it's trouble keeping up. Okay. But when we add these points here, you can see I did this one. I took a picture of my car here. You can see I had horizontal accuracy of about 13 meters. Andy was saying he used the GPS unit was down to less than 1 meter, so which is pretty good. I think I took a picture of the shed over here and I was at about just under 5 meters. So it might be exact, but the error tells it could be up to about 16, 17 feet off. And then Andy, I think he took this one right here. Fire hydrant 4, speed, vertical accuracy 9 point. So these were some of these that he took. Are there any particular ones that you took, Michael?
The new research building.
New, oh, okay, this one right here at the corner. Okay, good. The new research center right here, right at the corner. And you can see all the parameters that we collected. Now, what we're gonna do for this assignment is we're gonna create a new survey. Now, instead of going into field maps, what do you think you're gonna go into? Survey 1, 2, 3. And what I like to do is I like to create a brand new survey. And then we'll do the same exact thing, but instead of doing a field map, because that layer, landmarks 2024 or 2022, that was created by me, that I just let you use. Now you're going to be creating your own where these points are going to be accessible to you. And you can collect whatever, however you want as well. So there's a lot of a lot of interesting opportunities that you can add. You notice some of the things weren't input. So for when I took a picture of my car, name wasn't required. So you could set up survey 1, 2, 3 so that it can be, hey, you need to take a picture. You need the serial number on the telephone pole that you're collecting. You need to type that in before you can click the submit button. So this survey 1, 2, 3, I think is a little bit more powerful. We do this with COPE when people are collecting information for water quality. So we have different water quality stations and they'll go and, you know, collect the information about water quality. And we'll go to my surveys. This is a food environment survey that we've collected. And so where people were collecting information. In addition to these things have analytics attached to them. And so when we click on the design, what we did in class was we have the name of the collector and you see a little star right there. That means that it is required. And so what we had students do is go collect information about the local food environment. What was the date and time of the collection? That'll be collected from your phone. What's the name of the store? What type of food is this? And we saw that there were supermarkets, fast food, convenience store, other. What's a picture of it? Where are you from? How would you describe the access? How would you rate the food environment for that particular area? And what we wanted to do here was just kind of use various types of input parameters, both quantitative and qualitative input parameters that we can have. So you can see the design of this that we created. We had some drop down. So I click on the drop down and over on the right, you can see my choices. Autocomplete, this is required. Where are you from? How we describe access. So this is what we call a Likert scale. So typically 1 to 6, 1 to 7. Me, I always like having even numbers, so you can't select something right in the middle. You can't say, oh, it's good and it's bad. So you got to pick on one side of these or the other. How would you rate the overall food environment? And then how would you describe it? And then how would you rate the quality of it? And then this will be loaded onto your phone. And so for the assignment, and I'll post it specifically, is that when we click settings and share, basically what I want you to do is share this with everyone so that we can go to survey 1, 2, 3, or we can go to the discussion board and add these things. Okay, so I can access this, okay, for our class or whatever. So I just want you to kind of think outside of the box. What are, and a lot of times I just want to create area of interest. What are the landmarks? What about a landmark? I want a picture. I want the name of it. With the food environment, it's going to be a little bit different because I don't want to go back later and say, how affordable was everything? I don't want to go back later and collect these. So really think critically and holistically about all the different input parameters that you want to collect and create and the types of data that we have there. Okay, so I'm going to turn this off now. So Dr. McGinn and I and the department and the people here, we're going to be going to a talk about meteorites. I'm really excited about it. They got food. The food's already out there, and but we're going to have a talk about meteorites, and we should be good to go. Any other things I need to mention? All right, so I'm going to stop here. I'll see you all later, and we'll post the directions in a couple of hours when we're done with everything for that.
Thank you.
All right, thanks. See you later.